Hello everyone. In this session, we are going to see about the some topic called AVL tree, which comes under trees. In previous sessions, we were discussing about a normal tree. So why do we go for an AVL tree? In normal trees, when we're adding a data in the right hand side, I can keep on adding up a data on the right hand side if the input value is greater than the root node. So now what happens over here? What is the drawback over in the normal binary tree? So to the searching time will be very much larger because if I keep on adding a nodes on the right hand side, then it had to compare some large number of data to reach the data at the leaf node. So it requires more time. So to overcome the time efficiency, time consumptions, they have gone for an AVL tree. AVL tree is nothing but Adelson, Wilsky, and Landis. That's an AVL tree. So what's the properties of an AVL tree? So always it should be balanced tree. Always it should be maintain a balance. What is the balancing factor? So balance of every node is either it can be -1 or 0 or 1. So what's the formula here? For balancing factor, it's a height of a left subtree minus height of a right subtree. That is the balancing factor. So then here the maximum possible number of nodes in AVL tree can be 2 power h plus 1 minus 1, where h is the height. And then operation we can perform searching, insertion, deletion of a node, and time complexity is order of log n because we are keep on dividing by 1 by 2, 1 by 2 onwards because either I can go by right hand side or left hand side. So then in the right subtree also I'll go by left hand side or right hand side. So it's order of log n. So these are the introduction of my AVL trees. So now we'll go for a balancing factor. So now consider this tree. So for 25, I need to find the balancing factor. So now here, what is the balancing factor? Height of a left subtree. So now height of a left subtree is 1, 2, 3. Right subtree is 1, 2, 3. If I come by this way, 1, 2, 3. So 3 minus 3 it is 0. So now for this, for 20. So left subtree 1, 2. Right subtree of 20 is only 1. So 2 minus 1 it is 1. So for this, left subtree is there, no node in the left side. So 0. Right subtree is, there is only one node. So 0 minus 1, it is minus 1. So likewise, we have calculated for the balancing factors for all the nodes. So balancing factor for all the nodes can be observed as either -1 or 0 or 1. It can be in any one of those three values. It can be -1 or 0 or 1. So this is a balanced tree. So I can perform searching of a data in very much efficient way. That's the advantage of having an AVL tree. So now check this one. So for this node, okay. So left subtree is 1, 2, 3, 4. Okay, 4. Right subtree is 1 and 2. So 4 minus 2, it's a 2. It is an 2. So now what happens over here? The balancing factor is 2 for this. So now for this, 1, 2, 3. 3, right subtree is 1. So 3 minus 1 is 2 once again. So for this, left subtree is it there? No, nothing. So 0. Right subtree is 1 and 2. So 0 minus 2, it's minus 2. So minus 2. So for this, left subtree is 1. And right subtree is, there is nothing. So 1 minus 0, it is 1. So for this, left subtree is 1, right subtree is 1, it is 0. So for it is no left subtree, no right subtree, 0. So for 0, here it is 0. So now you tell me, now is it a balanced tree or not? It is not a balanced tree because we have got the value as a balancing factor as a 2, 2 and minus 2. So when will we call this as a balanced tree? When it is a -1 or 1 or 0. So when we have a balancing factor as a -1 or 1 or 0, then we will call it as a balanced tree. Then when we have more other than these three values, any values, it will be called as an unbalanced tree. So now to search a data in this tree is very much time consumption compared to the balanced tree. That's a drawback which we have in the normal binary tree. So to overcome this, what we will do? We will perform some rotations to make it as a balanced tree. So now this is an unbalanced tree. This is an unbalanced tree. So now we should make it as a balanced tree to make it as an efficient one. Okay. So we will perform different rotations to make your unbalanced tree into one balanced tree. So the rotations, there are two types of rotations are there. One is called single and next one is called double. In single, we have two types, left rotation and right rotation. And then in double, we have left right and right left. So now we will see one by one. So left rotation. So now in the left rotation, what we will do? Okay. So for example, you can see here, the balancing factor of this one is 45 is -1 because 1 and 2 and right subtree is 1. So 2 minus 1 is -1. And for this is left subtree is 1, right subtree is 1. So 0 balancing factor. For 27, there is one left subtree, right subtree 0. For 39, no left subtree, right subtree 0. So now when we add 18, into the balanced tree, so now what happens over here? This becomes imbalance. This node becomes imbalance. Okay. So now 45, 1, 2, 3, 3 minus right subtree is 1. So 3 minus 1, it is 2. So now what happens over here? It becomes imbalanced tree. So now what do we do? We will perform left rotation. We will perform left rotation. So now what we will do it over here? So if you observe over here, 45 and 36 and 27. Always for rotations, we will consider only three nodes. We will consider only three nodes. Okay, this is the node which is imbalanced, right? So now this node, and then the left side is very much larger. The left side is very much imbalanced. The right side is only one. So left side we should take. So 1, 2, 3 nodes has been taken. So 45, 36 and 27 has been taken. So then we will perform rotations. So now what we will do? We will put a nail over here and then we will make a thread and then we will pull the 45 to the down side and 36 to the root side and 27 to the above one side. So now what happens over here? So put a nail over here and then have a thread. So now pull this to the down side. So now what happens over here? 45 comes down. 36 goes to the root and 27 goes to the one side above. So now here 39 is dangling, right? So now we will take that and we will put it in the right side subtree. Okay, so this is called left rotation. Rotation. So what I'll do here, I will show one more example. I will show one more example here in this notes. You can see for left rotation. So now you can see here 30, 20 and 10. So what's the balancing factor of this one? 30. So the left side is 1, 2 and right side is 0. Nothing is there. So 2 minus 0, it is 2. So now what I'm going to do it over here, I have put a nail over here and then I have put a thread over there. I am pull it on the downside. So now what happens over here? 30 goes down and 20 goes up and 10 comes here. So this is called left rotation. I'll put a nail and then I am pulling a thread. So 30 comes down and 20 goes up and 10 goes up. So it is called rotation. This is called left rotation. So then now after rotation, you can see it becomes more balanced. Okay, for this left subtree is 1 and right subtree is 1. So 1 minus 1, it is 0. And it is 0 and 0. So now we will see in another example that is called an left right. That is called left right. So now what happens over here? 30, 10 and 20. So what happens over here? 30 uh, left subtree is going to be 1 and 2. There is no right subtree for 30. So 2 minus 0, it is 2. So it is imbalance. So now we need to perform some rotations. So in the previous case, it is fully on the left side. It is fully on the left side. But whereas here in this case, one is on left, another is on right. So that's why we are calling this as a left-right imbalance. We are calling this as a left-right imbalance. So now what do I do? So at first, I will put a nail over here. Okay, I'll put a nail over here and then I'll pull this ring. I'll pull this thread over here. So now what happens over here? 20 goes up and 10 comes down. Okay, I'm not considering 30. I'm not considering the 30. At first, I will perform the right rotation. I'll perform the right rotation. So now what happens over here? I'll pull this one. I'll put a nail over here and then I'll pull this thread to the downside. So 20 goes up and 10 comes down. So you can see here 30, 20 and 10. So still it is imbalance. Then I will perform left rotation over here. So I'll put a nail over here and then I'll pull the thread to the downside. So 30 comes down and 20 goes up and 10 comes in the left side. So this is called left right rotation. So here this is left right imbalance. So to make it as a balance, we will perform the right rotation first and then left rotation second. 2 steps. Okay, whenever we have a left right rotation or right left rotation, we'll perform 2 steps. For left left and right right, we'll perform only 1 step. Okay, this is called left right rotation. And next one is called right right rotation here. It's simple. So 10, 20 and 30. So balance factor is minus 2, minus 1, 0. So now what do we do it over here? I'll pull and put a nail over here. I'll pull a thread to the left side. So 10 comes down and 20 goes up and 30 comes in the right side of the 20. So now it becomes balance. This is called right right rotation. Just opposite to the left side. Opposite to the left rotation is called right right rotation. So in the left rotation, what happens over here? The tree is imbalanced because of the left subtree, two left subtree. And here the tree is imbalanced because of the right subtree. That's why right right rotation. And next one is called right left imbalance. Right left imbalance. So now here right subtree and then left subtree. So now here it is minus 2, 1, 0. It is imbalance, right? So always we will consider 3 nodes. We will consider only 3 nodes. So now if you see here, right left imbalance. So now what do we do over here? And for right left or left right, we'll perform 2 steps. We'll perform 2 steps. So at first I'll perform the right rotation here. So now what happens? I'll put a nail over here. I'll pull it to the downside. So 20 goes up and 30 comes down. So you can see here 20 goes up and 30 comes down. Then I'll put a nail over here. I'll pull it on the corresponding right side. So now what happens over here? 10 comes down and 20 goes up and 30. This is called right left rotation. So these are the 4 types of rotations which we have in the AVL tree to make it as a balancing tree. Okay, so now I will show you one example. So now here we will see this example. So now we should keep on inserting this data. So 63, it is perfectly balanced. And then 9. So since 9 is lesser than the 63, I'll put it on the left side. Okay, fine. Then 19, which is lesser than the corresponding 63, I'll put it on the left side. and 19 is more than 9. So I'll put it on the right side. So now see the balancing factor. So 2 minus 1, 0. So 2. It is the imbalanced tree. So now what do we do over here? It is which rotation will perform? Left, right rotation will perform. So at first it is a two steps rotation. So 19 goes up and 9 comes down, and then I'll pull a ring and then I'll pull it through. So 63, 19 and 9. After left right rotation. Okay. So for a more understanding point of view, so at first I'll perform this rotation. So now 63, 19 and then 9. Then we'll perform this rotation. So then 19 goes up, 63 comes down and 9. So then next data is going to be 27. So 27 means what happens over here, which is more than 19 and which is lesser than 63. So I will put it over here. This is fine. Then 18. So for 18, what happens over here, which is lesser than the 19, I'll put it on the left subtree. More than 9, I'll put it on the right subtree of 9. Okay, fine. This is correct. And then 108. So 108, which is more than 19, more than 63, I'll put in the right subtree. Then 99. What happens over here? 99, which is more than 19, more than 63, lesser than 108. So now balancing factor also 1, 2, and 1, 2, 3. So 2 minus 3 is minus 1. So everything is balanced. So the next one is going to be 81. So 81 means what happens over here? 19, 63, 108. So 81, which is more than 19, more than 63, and lesser than 108. I'll put it in the left subtree. So now what happens over here? It becomes imbalance. It becomes imbalance. So when it becomes imbalance, always, for example, you can see there are three nodes are imbalance. So always I will consider the very much downside node, which is first imbalance. So this node is the first node is imbalance, right? So whichever nodes are associated with the corresponding node, I will take it. So now what I can do it over here, I can perform left rotation over here. So 108 goes down and 99 goes up and 81 comes up. You can see here 81, 99, 108. So now it becomes more balanced. So since I have performed LL rotation over here, this node, two nodes also becomes balanced from imbalance. Okay. So this is called an insertion operation in the AVL trees. So now we will see another example. So now here 40, 20 is fine. 40, 20, 10. So it's imbalanced tree, right? So I'll perform left rotation. So now 40 goes that side and 20 goes up and 10. So then I will add 25. So 25, which is more than 20, less than 25. So it will be balanced one. And then when I add 30, this becomes imbalance. This becomes imbalance. Minus 2 and 2 minus 1, 0. So now from downside, which node becomes imbalance first? This node. So whichever nodes I will perform, I will take only three nodes. I will take only three nodes. So with this node, I have an left, right. I will take three nodes, left, right. So now I'll perform left, right rotation over here. So 30 goes up and 25 comes down, and then I'll pull it by for the left rotation. 40 comes down and 30 goes up and 25. You can see here 40, 30 and 25. It becomes balanced. After that, the next input is going to be 22. By adding 22, what happens over here? This node becomes imbalance. This node becomes imbalance. So now here, uh, which side is imbalance? Right side is imbalance. Okay, because it's minus 2. If it's a 2 means what? Left side is imbalance. So since it's minus 2, it's the right side is imbalance here. So you can say here right, and then so you can go by for either by means of right side or left side. But for the 30, the left side is very much larger value. 25 and 22, two nodes are there. Right side only one node is there. So now we should consider the right left rotation. right left rotation. But generally what we tends to do means we will take 20, 30, 40. But we should not do that. Why? What's the reason? Because for 30, the left side is very much heavier than the right side. So we should perform right left rotation. So 20, 30 and 25 should be considered. 20, 30 and 25 should be considered. So now what happens over here? So 30 goes down and 25 goes up. And then 20 goes this side, 25 goes upside and 30 will be there. You can see here 20 goes this side and 25 goes upside, and then we have a 30. So then there's one node which is attached to the 25, 22 is there. So we will take the 22 and then we'll put it in the left subtree. We'll put it in the left subtree. So now what happens over here? After adding that, after performing the RL also, then we have added one more data called last data called 50. So we have added 50 over here. By adding 50, what happens over here? This node becomes imbalance. So it is fully right, right. So what we will do? Simple. 30 goes down and 40 goes up and 50 in the right subtree. 30 goes down, 40, 50. Right, right rotation. This is called an AVL rotations, which we perform always imbalance tree to the balancing tree. By doing it so, what's advantage? The searching time will be very much lesser than the normal binary trees. Okay, thank you.